So let's get started with the Chapter 5 practice test. Start with question number 1. The first three terms of a geometric sequence are -3, 3 squared 2, and -6. Find the general term of the UN of the sequence. Well, to find the general term, first we need to identify U1 and also the R, the common ratio. Well, U1 is easy, it's just -3. But how do I find the common ratio? I think I'll find the common ratio by finding the ratio between the two consecutive terms. So I think I can achieve that by doing 3 squared 2 divided by -3. Cancel out 3's and 3's. I can get negative square root 2. So I know that my common ratio must be negative square root 2. Then plug in the formula. Un is equal to u1 times r to the power of n minus 1. Therefore un is equal to -3 multiplied by negative square root 2 to the power of n minus 1. Find the sum of the first 25 terms of the sequence. Well, let's plug in the formula as well. So, first of all, using the same u1 and r values, I just have additional information that n equals 25. So let's first copy down the formula for the sum of the first n terms of the geometric sequence from the formula booklet. Sn is equal to u1 times r to the power of n minus 1 divided by r minus 1. So S25 must be u1, which is -3, r, which is negative square root 2 to the power of 25 minus 1 divided by r, which is negative square root 2 minus 1. I think that's all I can do for now. I can try to simplify if I wanted to, but I don't have to. At this point, we can use the calculator to compute this value. Right? So let's do that using the calculator. Bracket -3, close bracket, multiplied by open bracket, close open another bracket, negative square root 2, close bracket, to the power of 25 minus 1, close bracket, divided by open bracket, negative square root 2 minus 1, close bracket. So I think the answer comes out to be S25 is approximately negative 7,199.39 approximately. Right, moving on. Three consecutive terms of a geometric sequence are k, 20, and 25 over 4 times k. Find the possible value of k. Well, the first thing that we know about the geometric sequence is that there must be a common ratio. I can find the common ratio by finding the ratio between two consecutive terms. So it's going to be 20 over k. That's one way to find it, but we also know that because it's common, that it's also equivalent to 25 over 4k divided by 20. At this point, we have an equation. We have 20 over k is equal to 25 over 4 times k divided by 20. So let's solve this equation. So I can use cross multiplication to get 400 is equal to 25 over 4k squared. I can multiply both sides by 4, or multiply by 4 divided by 25. I think I get 1600 divided by 25 equals k squared. And 1600 divided by 25 will be 64 equals k squared. Then we get k equals to plus minus 8. Make sure that we know that we have possible plus minus values at this point. For each value of k, find the next term in the sequence. Well, to find the next term in the sequence, we need to know what our common ratio is. Well, we found the common ratio as 20 over k. So I think I can say it as 20 over plus minus 8 would be plus minus 20 over 8, 5 over 2. I have one information. So about the thing. Can I answer after? Okay. So knowing that r is plus minus 5 over 2, let's also find that 25 over 4k to find the third term, or the term 25 over 4k, would be 25 over 4 times plus minus 8, which is going to be plus minus 50. So we can say now, if k is equal to positive 8, then my next term after positive 50 will be multiplied by 5 over 2. So I think that will be divided by 2, 25, multiplied by 5, 125. Next term. If k is negative 8, then my 25 over 4k is negative 50. The next term is negative 50 multiplied by negative 5 over 2. So that's also 125. Next question. $5,000 is invested in a savings account, where the interest rate is 1.3% per annum, compounding quarterly. After several years, the final value turns out to be $6,916.51 on a number of years. Well, that's organized information that I do know. So I do know that my PV is equal to 5,000, current value. Also, my interest rate is 1.3%, so let's say R is equal to 1.3. It's compounding quarterly, so that means that k equals to 4. And also I know that FV is equal to $6,916.51. And I don't know. So at this point I can bring in the formula. Copy down the formula first. FV is equal to PV times 1 plus R over 100k to the power of Kn. FV is 6,916.51. PV is equal to 5,000 times 1 plus R is 1.3. R 100k is 100 times 4 to the power of k is 4, and we don't know. So at this point, I definitely know that I do not have the ability to solve this question at this point of our curriculum. So let's use the graphing calculator. So I'm going to plot y1 is equal to 6,916.51, y2 is equal to 5,000 times 1 plus 1.3 divided by 400 to the power of 4n, 4x. So let's go. Y equals 6,916.51. On the next line, I'm going to plot y equals 5,000 multiplied, open bracket, 1 plus, open bracket again. I'm going to put a bracket around the division just to make my life a bit safer. 1.3 divided by 400, close bracket, close bracket, to the power of 4x. Now, I also need to change my window setting slightly. Because I know that one of my line is 6,960.51, that means that I have a horizontal line at y equals about 7,000. So I think I'm going to put my y maximum to at least 10,000. And then I see the graph a bit better. However, I need to extend my x value a bit higher. I don't care about the negative x value, so I'm going to put my x minimum as 0. But instead, I'm going to put my x maximum as, let's say, 30. So when I switch my window one more time, I do see that I do see the intersection point. And if I calculate the intersection point by doing second trace 5, and then enter after you scroll, I get x is equal to 25. So therefore, we can say that it would take 25 years. Next question. The initial price of the Tesla Model X is $142,990. This resale price decreases by 8% every year. How much is the resale price of the Tesla Model X in 20 years? Well, this is kind of an application of a geometric sequence question. So we need to use the geometric sequence formula. We know that un is equal to u1 times r to the power of n minus 1, but this is only for a geometric sequence, and it's not so applicable for our application model. So for the application model, we use a similar looking but slightly different a equals I r to the power of t. If you don't remember this formula, well, you can try to make it somehow from here. But let's plug in our values that we know. So we know that initial price is 142,990, and we know that R is equal to, well, R is decreasing by 8%. So for me, that sounds like, sounds like 100% minus 8%, which is 92%. So I'm going to say that my rate is 0.92. Okay. So I know that my R value of less than 1, like between 0 and 1, does give me that decreasing value. And in question number part A, I know that n is equal to 20. So let's plug in the values. A is equal to 142,990. Sorry, 142,990 multiplied by 0.92 to the power of 20. So this one, we just have to use the calculator to compute it. So I think my answer would be 142,990 times 0.92 to the power of 20. So my final answer is 26981.26, rounded at nearest 100. So that will be my final price after 20 years. Part B. How many years will it take for the price to fall below 100,000? Well, to solve this question, this time I want my A value to be 100,000. So this time I don't know N, so let's plug in the formula once again. A is 100,000 is equal to I is 142,990 times 0.92 to the power of N. So once again, I don't have the ability to solve this question, so I'm going to use my calculator. Y1 is equal to 100,000. Y2 is equal to 142,990 times 0.92 to the power of X. So let's use the calculator one more time. Once again, this time, I'm going to plug in the values. So right off the bat, I know that my first line, y 100,000, it's a horizontal line at y equals 100,000. So I'm gonna assume my I maximum to be extremely high. So I think it's gonna be good if I choose my y maximum to be, let's say, 150,000. My y minimum can be 0, and if you have resetted your calculator after the previous question, your current window should be negative 10 to 10 for x-axis and 0 to 150,000 for the y-axis. And you do see the point of intersection right away. And do see the point of intersection at 4.289. So we can say x is equal to 4.289. Now to answer the problem, how many years will it take for the price to fall below 100,000? Well, it's going to take more than, if I say 4 years, if I round down, it's going to be incorrect because after 4 years, it won't be less than 100,000. So it'll take 5 years to go below 142,990, sorry, below 100,000. All right, final question. Consider the sigma notation below. Um, the sum of 50 times 2x minus 1 to the power of k minus 1 from k equals 1 to infinity. So right off the bat, this sigma notation looks kind of weird because it involves an infinity sign above the sigma notation, which means that it must be an infinite series. Now, remember that infinite series does exist when the series converge. And we also know that from the formula for the infinite jumper series, which you can copy down here, S infinity is equal to u1 divided by 1 minus r, where r, absolute value of r is less than 1. So I do know that my series converge only if my common ratio, or absolute value of the common ratio, is less than 1. Now, well, I don't know how to start this question, so let's start by writing down some first few numbers, first few terms of this sigma notation. So let's start with k equals 1. When k is 1, my power is 1 minus 1, so that's 0. 2x minus 1 to the power of 0, everything to the power of 0 is just 1. So my first term will be 50. Let's write it like this. Is equal to the first term is 50. What about the second term? My second term is when k equals 2. K equals 2. 2 minus 1 is 1. That's going to be 50 times 2x minus 1. Plus my third term, when k equals 3. 3 minus 1 is 2. So at this point, it's easy to identify, or you didn't have to if you realize that the expression is a general term of a geometric sequence. We know that u1 is equal to 50, and we know that column ratio is equal to 2x minus 1. So now, to answer the question, under what conditions will the series converge? Well, we need to find so that the common ratio r is 2x minus 1, or absolute value of it is less than 1. Now we need to solve this inequality question. We can solve this in many ways. We can try to use graphing calculator or whatnot. Well, let's try to solve this in a couple of different ways. First, if I have absolute value of 2x minus 1, it means that it can be either positive 2x minus 1 or negative 2x minus 1. So I have two different cases. So we can say 2x minus 1 is less than 1, or we can say that negative of 2x minus 1 is less than 1. Okay? Or if you don't like this, you can also just use the definition of absolute value of r is less than 1 and say, oh, I don't like that. We'll just say that r is between negative 1 and 1. So if you say that, then you can use 2x minus 1 is less than 1 and it's greater than negative 1, which these two are two equivalent statements, right? So if I solve for 2x minus 1 is less than 1, well, it's going to be 2x is equal to, 2x is less than 2, so that has to be x is less than 1. If I solve for the other case, negative 2x plus 1 is less than 1, negative 2x is less than 2, less than 0, so we can say x has to be greater than 0. Notice that when I divide both sides by 2, the sign, inequality sign changes position. So my final answer would be x is less than 1 and it's greater than 0. Part B. Evaluate the sum if x is equal to 0.3. So let's evaluate the sum when x is equal to 0.3. The sigma notation looks like this. 50 times x is 0.3. So 2x minus 1 would be 2 times 0.3, which is 0.6. 0.6 minus 1 would be negative 0.4 of k minus 1. So we know that u1 is equal to 50 and r is equal to negative 0.4. So now let's plug into the formula. S infinity is equal to u1 divided by 1 minus r, where common ratio is less than 1. Just now we can check that r of negative 0.4, absolute value of it is indeed less than 1. So we are allowed to use this formula at this point. u1 is 50, r is negative 0.4. So using my calculator, I can do 50 divided by 1 minus negative 0.4 is 1 plus 0.4 is 1.4. So 50 divided by 1.4 would be approximately 35.7. That would be my final answer. Can I answer the question? So the sum of the series when x is equal to 0.3 would be about approximately 35.7. So that concludes the solution of this practice test. Hopefully you enjoyed it and good luck in your actual test. Bye bye.